Hi, CityJS people. I'm sorry I couldn't be there live today, but I was still very excited about this conference, and I'm really happy that the Singapore tech scene is coming back alive after COVID. And so I wanted to present to you something I've never talked about in public before, which is why I'm exploring data engineering. And I call this the data blind spot, and it's based off of a discovery or tweet that I made that really surprised a lot of people. So I'll give you some context. The first context would be one of the most interesting applications that I've seen, or one of the most interesting side projects that I've seen. So this is Archive on the left, which is a open repository of a lot of research papers that people have come to really rely on. On the right is Archive Sanity, which is Andre Karpathy's layer on top of it that adds a few interesting things like recommendations, search, better search with interesting um, recommendations on top of that. Actually, let's just go for the feature list. So keep track of recent papers, search for papers, sort by similarity, see recent popular papers, add papers to your personal library, get personalized recommendations. And he made it for himself essentially because there was just too much going on in the regular archive for him to keep on top of it. He needed the help of data to make sense of it and to make it more usable. And I think a lot of people agree. Whenever you see comments about archive sanity, they'll say things like archive sanity is a lifesaver. And that's something that shows that you really have some kind of traction there. And I think this is a generalizable principle of web applications that if you add some kind of intelligence on top of existing data, you make a much better user experience over and above just UX and accessibility improvements. And this is something that I think the traditional web development discourse is completely missing. So let's talk about that. Obviously, Andre is head of machine learning at Tesla. So he is very motivated to talk about the benefits of machine learning. But his whole thesis is that this is the next generation of software in general. Like software 1.0 was able to create a single point in time where the amount of complexity that we can handle is the amount of complexity that we can code. Software 2.0 is limited by the amount of data that we can feed into our programs for them to figure out what to do with it. And that is just categorically a much larger space of program complexity than software 1.0. Obviously not entirely suitable for the same thing. They don't have an overlap there, but it is a whole new space for people to explore. So use cases that he laid out in his blog post, you should highly recommend reading it. Visual recognition, speech synthesis, blah, blah, blah. But I think the thing that has caught the public attention recently and that he didn't anticipate is text and image generation. And that's something that's really useful as well. There are also some really interesting underlying principles that make machine learning more tractable as a problem than regular computing, which is very interesting. But this isn't a machine learning talk. This is just his take on that, which is one form, one application of enhanced data. The domination of algorithms, I think, is perceivable throughout our existence. Obviously, everyone is familiar with Netflix and their recommendation prize that they launched in 2006. But for them, everything is a recommendation. TikTok defeated Google by being a better recommender of content. And even the way that we date and form relationships is driven by algorithms as well. How much of our lives is driven with interesting usage and application of data. So I want to talk about our mental models when we talk about tech. I want to talk about how we can expand our discourse in conferences like this one to better match what is more useful to users and to work on more interesting and hopefully profitable problems. So a lot of the times when we talk about different models of web development, we're really debating relative sizes of the client and the server. Like Web 1.0, maybe server heavy, maybe a bit more on the client. Ajax, smart clients, Jamstack, Edge first. Sometimes, I think there's really good benefits and merits to a lot of different architectures, but ultimately, if you're constrained to a two-body problem, then you are essentially limited to just discussing different percentage mixes of that. What then evolves is, all right, if you want to make it a bit smarter, throw a database on top of everything. There was a really interesting conference recently called "Have you tried rubbing a database on it?" which is just a fascinating application of that. And I think yes, in general, most applications become more interesting when you can store some of my preferences or my information and make use of it, right? So everything just becomes more interesting when you just add a database. Things also become faster sometimes if you want to use an embedded database, which is something that people are really exploring, just bringing the data closer to the client and maybe cutting the server out or syncing with the server as an afterthought rather than a critical path issue. But even that is still not entirely good enough for me. So when I think about types of applications, I often think about Jason Miller's blog post on application holotypes, where he really went through the sum total of the web and said, like, all right, what are the main use cases of the web that we have landed on over the past 30 years? And in social network sites, social media apps, I don't have to read all of this to you. It's clearly pretty diverse, and you probably want to use different types of technology to solve these problems. So this may not be the best categorization, but it's the best one I've seen so far. If you have a better categorization, or if you see a major category that is missing from here, let me know. But basically, I want us to grow beyond just blocks. Anyway, so so I went through this list and I said, which of them require intensive data, and it pretty much is the largest use cases by market cap. Anything that uses intensive data is inherently correlated with very, very high revenues and valuations and money. So I think that's one motivation for doing this. And I think if you re-examine the data paradigm, the client server paradigm, to include a client server data paradigm, you start to have a different conception of full stack. What we usually mean when we say full stack is client server or client server with a smattering of database. But really, there's a category of applications that are growing and that we were not really discussing because we don't view it as our job. That is data intensive, that has a much bigger chunk of data to it than we've been led to believe by the relative proportion of discourse that we spend on conferences like this one. And I think the reflection is borne out if you look at the relative interest in job markets. So, I think as successful as front-end engineering has been over the past 10 years, back-end engineering has also grown in a lot of traction. Full stack engineering has surprisingly not caught on as a term. But relative to all of those, if you just chuck in data scientist, data engineer, they all pale in comparison. It's just so massive because, partially because of the enterprise. Maybe it's a meme in the journalism, but clearly there's something going on here that we haven't really captured in our regular discourse. Data intensive also undersells it. I pictured them here as relatively equal boxes, but really when you want to get really data intensive, you can get very, very data intensive. And that's something I'd like to explore here. So you have the client, you have the server, and then underneath that iceberg, you may have a whole ecosystem of first-party data, post-processed data of the first-party data, and third-party data that you pull in from other sources, right? And I think once you start exploring this universe, it is a very, very deep rabbit hole. I've only just begun exploring it, but it kind of looks these are a few of my favorite images about that. So one of the ways you can think about it is that you can ingest data or collect data, put it in a warehouse, organize, visualize, and present it to other people, but then also automate it by putting stuff up in terms of automated posts or feeding data into the ultimate destinations that you want to do. You can organize it by use case. So again, this is another image that I found online where you're pulling in the data using data warehouse like Snowflake, and then applying it into your web applications or enterprise applications or data science or doing reporting, and then feeding into machine learning. If you want to have a much more machine learning centric kind of application, you're going to probably build it right into your hot path. And so these are just different architectures, right? This is the most comprehensive where it's really given a label to each of the components of the workflow that you might want to have. And ultimately, my goal here is not to teach it just because I don't myself know it fully yet. But I think there's something here. I think that it's something that we don't discuss as web developers. And I think my message is to not to try to go for everything right now. Start at the basics. Start by collecting data, um, creating data pipelines, understanding how to structure data and to model it, and then to do things like spam detection, anomaly detection, cleaning data, recommending, and then doing recommendations, A/B testing, and all that good stuff. This is not a machine learning talk. This is about data. This is about however much we talk about improving user experiences through better UI. We don't really talk enough about improving user experiences through giving them more data than a better view of data than they can possibly have on their own. Um, so I'll end it off with this. If you're a front-end developer, or if you're primarily front-end, you're very familiar with the concept of V equals FT. It's on a lot of React talks in 2015, 2017. And here's me in 2018 talking about V equals FT. It states that view is a function of data. And I think as front-end developers or as UI and UX developers, we're very used to improving the F given a set of D that a backend developer might provide to you. But really, if you have a lot of skills on the F, maybe it's time to work on the D. So that's my talk. I hope you really enjoy it. I wish I could be there to hang out and explain more about why this field is interesting. But basically, I hope that you start thinking about your data blind spot. Cheers.